So there was a Unite in Los Angeles last weekend. I didn't watch it. It's kind of a shame. I wish I was there. Apparently somebody says that I was one of his favorite Unity YouTubers. By the way, thank you. Had a great effect on the channel. Good day for the numbers. You hold a special place in my heart, just like this tick boy. While everybody was listening to Unite, the second day, so ECS day, I was driving a total of 22 hours to get this nice little boy. It's Shibe. He's exactly 12 weeks old as of tomorrow, so not 12 weeks old right now. His name is... I need help. I need help to name him, actually. Right now he responds to Pepe, because I was thinking it was quite funny to call him Pepe the dog. It sounds like Pepe the frog, or Pepe the Shibe. But that's not gonna work, and he really likes to bite at the moment. He's really playful, really healthy. He had a cold when we got him, but all the cold symptoms are now gone. I fed him the medicine. Okay, I'm gonna put him down because this desk is too high for him. But yeah, he's a healthy 11.87 weeks old puppy. He's bilingual, doesn't have a name. Oh, when I mean bilingual, I mean he knows one word in English and one word in French. He knows how to sit in English and he knows how to stay in French, so that makes him fully bilingual. The Shibas are actually quite stubborn at the base, so they are a hard breed to teach. But yeah, I got 2 words in there, so I got the stay and also the sit. Basic stuff. Oh, also, I got them to know where to poo. So my house is a lot cleaner now, but my yard is full of shit. But that was mostly last week at the same time I was releasing those videos for the LL API. Now I came back, I watched the whole live stream, the 9 hour of live stream, which is basically maybe 3 hours of content and the rest is just pause. I watched all of that, including the pause. I will now talk to you about ECS and the state of ECS today. It's a topic I haven't really took seriously until very recently, until they had this talk, and this inspired me to go a little bit further and research more into it. You can see it as some kind of recap of the talk, but you're gonna have to look for 10 minutes instead of looking for 3 hours. Am I dropping Classic completely? No, there's no way for me to drop Classic at the moment. My approach going inside of ECS code is to create things with ECS that are going to stay, so things that they mention are going to stay. Which brings me to why I am using an hybrid approach at the moment. I have an hybrid approach simply because I was making an achievement system recently and I needed to fire events, but events are something that they still don't know what is a good practice to do. Like, they're still working on a good API, a good workflow to fire events. There is a couple of ways to do it already in ECS, it's just something that is subject to change. Just like the inject attribute, they don't want to keep that, that's too heavy. Obviously I don't want to be using any of that in my code, I want to have code that stays there. So the places where they say they might deprecate it, inject, events, I'm simply going to be using Classic so we don't lose our time doing code that is going to get replaced by the new API. Having that said, let's jump right into the presentation and I will go over a couple of key things. This is an example of what ECS is capable of. Right now on the screen, this is a video from Unity themselves. This is an introduction to ECS. Right now what you see is a Classic implementation. He has about 19,000 chips and he averaged 29 FPS. Now this is the same game, the same chip, but this time with the ECS structure. And he can hold up to 96,000 chips with an average of 30 FPS. So he's even getting better performances than he had before with a lot more object. And now finally what you see right now is ECS and also the burst compiler in action. So to average that 30 frames a second, he can go up to 156,000 chips this time. This is a crazy upgrade from what he initially had with the Classic way of coding. So this is what ECS can do for you. First off, what is ECS and also what is it used for? Now, when we speak about ECS, it's kind of weird, but we're speaking about 3 different things, including ECS. When Unity speaks about ECS and they host a day, like a full day about ECS, they're not just speaking about the new way we're going to be coding Unity, but also the job system, the burst compiler as well. And ECS is just one more of these features. They just like to call it ECS, and they just wrap everything in it. So what is ECS? ECS is a new way to code that is data-oriented. So we're kind of moving away from object-oriented programming and we're going inside data-oriented programming. To support multiple operation on this data, we can now use the job system, which is basically a way to create multi-threaded code in Unity. If you ever try to create multi-threaded code in Unity right now using the classic approach, it's a pain, a lot of race condition, a lot of problem can arise from that. However, the job system helps us through this process. And finally, the third one is a burst compiler. So by creating this technology about the ECS, like creating this new way to code, creating this new job system, they learned a lot about this process and they also decided to create their own compiler, which basically helps everybody, even helps people with classic coding manner. So to recap, there is three big new things. First, ECS, the new way to code, data-oriented code. Second, the job system. That's going to help you create multi-threaded code. And third, the burst compiler. They all work by themselves. You can implement burst compiler on your classic code if you want. You're going to get a slight performance gain. You can implement jobs by itself. You're going to get a slight performance gain. And you can also implement ECS without using burst or without using the job system. They're all individual, but they work the best if they are together. Now, what's the point of these three new features? Why would I want to switch to data-oriented programming if you're already used to doing object-oriented programming? Or why would you start doing multi-threaded code? Well, that one's kind of obvious, right? So you're just doing it to get better performances. That's their motto going inside of ECS. They want to be putting performance by default, so as soon as you write your code, it's going to be optimal, it's going to be performant. Something that many people speak about or talk about when they look at Unity Engine. They say, oh, that's too big of a overhead, that's just too much stuff running that I don't need. Well, Unity is moving away from that. Unity is going to allow you to remove physics, to remove lighting. If you don't need those things, they're going to allow you to create the smallest executable file and just be able to compete with other engines that don't have this problem. So this is quite something big. Just to give you an idea, we are developing a game at MGN Studio, the place I work, and we are creating a web game. So we want something that runs through WebGL, and we build the executable for that. We built the whole file for the browser. Our big problem is that we're hosting that in a browser, and it takes us a good 4 seconds to actually start the game without even streaming any data. So if we just create an empty project and we put it in WebGL, we have a 4-second delay before the game starts. And if you're using the internet, 4-second delay to load something is a lot of friction. We lose a lot of people right there on the spot, and we'd like to lower that by quite a lot. So ECS is going to allow us to do that. ECS claimed that it can have build size, empty build size of about 76 kilobyte. That's what I saw earlier. They say that their goal for a simple game through a browser would be to load beneath 1 second, so it's going to take less than 1 second to actually load the game. That's what they're pushing for. That's what I'm really excited about. I think it's going to be quite cool because we're going to be able to compete, finally compete with, say, Go.2D, just for building a small executable on the phone. Yeah, we're there. We're able to do that with ECS. We just got to change our way to program. We're just going to change our way of thinking, actually, and go in with a different approach. I've talked about WebGL because it's something that directly concerns me, and it's something that we work on at my workplace. But it also works for mobile. It's going to reduce your battery consumption, which is a big problem with Unity game. It's also going to make sure your phone doesn't go hot super fast, and of course, it's going to wear it down a little bit slower than with a classic Unity game. With ECS, we're moving away from game object and component. This kind of way of creating things, dragging an object or creating a null object in the scene, and then putting your script on it for a behavior, is going away with ECS. This is not how we're going to tackle problem. This is not how we're going to code. We are still doing it, even right now. If you're trying to do pure ECS, you're still going to be doing that, like placing game object in the scene and putting a behavior on top of it. But in the engine, it's converting it from this way of going. So if you say you're using entity, it's going to take your game object and your component, and then it's going to crunch it down into ECS code format. And in your runtime, so in your .exe, you're not going to have any notion of that game object. So it is still being used right now, simply because we need a way to work, and the new UI, the new interfaces, the new API to work with ECS is not ready just yet. So why do I mention this? I mention this because we're moving away from game object, we're moving away from scattered memory. What I mean by this, if you create a game object today, you're going to be forced to have a transform. That transform, as a component, has multiple things in it. It has the position, scale, orientation. It has these three things that you know well about, but it also has more than just that. You can have a transform up, transform forward, back, just to know in which direction these arrows are pointing in terms of your object. It also has a couple of different fields, and it has a get child, it has a lot of things on it that you might not need. And these things are scattered around in memory. They're not just all tightly packed in one spot. That's not true. There's your game object here, there's your transform over there, there's your transform up down here, and if you just go around and try to fetch all of this, it's gonna end up being a mess for memory. You're gonna have to jump from one place to another in memory, and that's not what ECS want. ECS want to make sure that all your data is tightly packed in one little corner, and they know exactly how big that corner is, and they can just access stuff directly in there, and thus optimizing a lot of the CPU cycle we have to access those things. So we're gonna avoid missing L1 cache, missing L2 cache, missing anything that the CPU can keep at the top of its stack. We're going to avoid jumping from one place to another and basically make sure everything is tightly packed. This is really great for everything Unity related. For all the system in Unity, this is already really great. Rendering, lighting, physics, all of that will benefit from knowing where the data is and not having to jump around a couple of places. So if you're trying to render something, you need the game object, you need the mesh renderer, then you need the instance of the mesh. This is now all at the same spot because you actually going to define your ECS entity and they're going to know where it is basically. Extremely good. This is going to make rendering a lot easier because you can batch all your rendering in one spot of the memory and you don't have to jump around, as I mentioned. Yeah, we get some great improvement over there as well. If you watched my last video about unit deprecation, you know that we're dropping LL API and also HL API for the network code, multiplayer code. Well, they rewrote it using ECS. And this is so cool. This is actually really, really cool. Why? Because we're going to be able to get a good load off the server by having this more optimized code. And we're already coding in a data-oriented manner on the server anyway, because you don't have any renderer, you don't care about what you're showing on the screen. You just want to put as little data as you can through the bandwidth. So you're already thinking in a data manner. And I think the transition to ECS is going to be the easiest done on the network code. Maybe not so much on things that require, say, camera, player movement, all that kind of stuff. That might be a little bit harder than just straight up server code. So I'm quite happy about that. About 30 minutes in, they also show what could be the next editor, how it could look like if you're editing for entity. Now, of course, they're going to be keeping the classic editor, the classic way of doing things, the classic editor, basically, one we have right now. But they also want to create their entity editor, and that is for people that are going to be using ECS, or pure ECS for that matter. Why does this matter? Because in ECS, you don't have a hierarchy. If you have object, if you have entities, you do not have an object in the scene that is going to define it, not in the hierarchy. It's going to be in the scene, it's going to be in the game, you'll be able to see it in shaded and wireframe, you're going to be able to basically see the object, but you won't be able to click on it. That's not part of the ECS, that's not part of the way they want to lay down data. Instead, you might have one object with a renderer on it, and that's going to render a batch of things. Just think in matter of batches, so they're just rendering batches of things, and you might have one place that control it, or in pure ECS, I don't even think you have one place that control it, they just find it in your data and they render it. A little bit later in the live stream, they also talk about which system you need to create a game engine and to have it work well. They mentioned they're trying to recreate all of this system using ECS. I don't believe that any of those is actually ready, but they say they've done a lot of work on graphics, so we see that with the new pipeline. Animation, I'm not so sure, they didn't mention that. Actually, they said that they didn't really advance on that. Audio, a lot of work has been done. There was a presentation about that in the live stream. Physics, not so advanced. AI, not so advanced. Netcode, they have a good bunch of code ready for that. And also input, we know that there is the new input system on their GitHub, so we might have a preview of that. Now, I don't think any of those are ready, as I mentioned, so we're still in a very early state, and things can change in every single one of those systems. This was a brief overview of the beginning of the live stream, where they talk about a little bit of everything, but they don't go in depth so much. The second presentation talks about how they're crunching all of that data, how they're rendering that data in the scene to make it more fast, to make it more optimized. So basically, just one example of what they mentioned here is they take every children object and they bump it back up to the parent, which means that now those objects they're transformed is directly the world position, and it's not, they don't have to go through their parent to get the real position, because if you go inside of the children, you have the local position, you also have the world position. Well, they get the world position right away by bumping everybody up again. And they have a bunch of other examples like this. So if you're interested in how they actually did it, how they get every single little bit of optimization they can, I really recommend you to watch the second presentation. In the third presentation, they go over how they've created the demo scene. So they go under the system, so especially the traffic system and also the lane merging system. They have a lot of car being spawned and also running on these fake roads. Also very cool. If you want to learn more about how they created the scene, what system they use, and how they went about fixing some kind of problem, then feel free to watch the third presentation. It is some quite, it's very cool to see it in action and have some actual examples. During the presentation, they also look at code and also break down, as you can see here, they break down the profiler to know exactly, what's going on, how long it takes for them to update the traffic system that they've made. In the fourth presentation, they talk about burst and how big of an upgrade it is. So as you can see on the screen here, Mono can be 30% to 3 times slower than .NET, which means that your classic way of coding could be 3 times slower than just doing pure .NET. And then Mono can be 10 and 30 times slower than C++, which means you're actually quite far away from C++ performances. Your game in Mono could be 30 times faster if you wrote it in C++. And that's something they're trying to achieve. So they're trying to convert, well, not convert, but they're trying to take the time from Mono to something that's more towards C++, of course. And that's why we have Burst. As I mentioned, Burst is going to help everybody, even Classic. Now, of course, if you're trying to go for that 30 times gain, you're going to have to use more than just Classic and Burst. You're going to have to use Burst, Job System, and ECS all together to achieve a crazy amount of more performance. Is that English? Doesn't matter. So, yeah. Burst can be used in Classic, in ECS, and it's just something you toggle on and off right now. There was a Q&A session in the first presentation that mentioned, why do we not have Burst by default just yet? And the answer was basically, since it's still in early beta, it's not there by default simply because there might be bug. But there is no reason for somebody who's experimenting to not turn it on, so to not get this free performance boost. And that's just cool. That is Burst. In the fifth presentation, they talk about audio. I don't know much about audio. I kinda sucks about audio. They do mention, they do show some code, but they also say that the API is subject to change. If you want to learn more about audio, I really recommend that you actually watch this. I tried to watch it for about 10 minutes, but I could not really follow. I'm not an audio guy, and when they started making some reference with Wise, I got lost. So, the big thing that I got out of it is this, which is true for most of what we saw today. In the sixth presentation, they speak about how they've created the demo scene with a bunch of artists, so outsourcing artists, and they show some incredible number right here on the screen. 4.5 million mesh renderer, and they all run in the scene. They're all loaded in the editor, but of course, they're all loaded and viewable in the editor, but if you go on the game itself, of course you have some calling going on. They achieve a good FPS rate with 4.5 million mesh render. That's just what we wanted forever. I just wanted to share this number. I thought it was really impressive. 4.5 million mesh render is just, yeah, crazy. And then he moves on to speaking about the workflow and the pipeline they had for creating this scene. So he mentioned having a nice, very, very nice mockup, like spending a lot of time on the mockup so everybody could start working in parallel. With a nice mockup, with some rough texture, rough colors, he was able to nail down the color palette for the artist. He was also able to nail down a good idea of what the scene is going to be like for the audio guy, and start working all in parallel so they can ship this in 2 weeks, I believe. Next presentation is about debugging. As I mentioned, we don't have game objects in the scene. We can't click on them. We can't really know where they are, what the data is. So the product they're trying to achieve with Debugger is something along the line of the state machine, so mechanism per se. They would like to see, have all your system laid down like this, and when you run the game at runtime, you have links that shows you exactly what system is being used and how it's all working together. Now, he also mentioned that it's never going to be as clean as this because you can have a lot more system in your game, but that's the goal. The goal is to have a visual debugging, well, maybe not debugging, but visual representation of your code and how it runs in the background. And I think that is so cool because it's going to help me make videos. Assuming we're making a scene, before I go and I show you, like, talk about the system, I can just show you a screenshot of what it looks like in that. And I think that's going to help. Like, I'm actually looking forward to this quite a lot. In the next presentation, our friend Fabrice and Simon are looking into the streaming and serialization of the entity component system. So this is everything related to how they pack memory, how they make it so it's really tight, and they don't miss caches, CPU caches. Yeah, if you want to learn more about that, you look at the before last presentation. I lost track of the number. And finally, on the last presentation, they speak about the future of the API. So how we, the coder, are going to interact with the engine. So how exactly we're going to write our code. And this goes back to what I've mentioned at the beginning. So here they talk about things that are not really efficient and also will change in the future. This is where she mentioned not using inject in the future, because they take a deeper look instead of inject and you realize that it's using reflection and also C# list, which is not something that is fast, and that's not something that they want to keep. So here they basically mentioned that inject is a problem and they're going to be moving away from that. I was speaking also about events. That's a personal case for me, basically. It's not something they've mentioned here. It's something they've mentioned in the past in May. So they were speaking about events and not having a good way to actually solve that problem. Which leaves us to this comment. So that's something we should think about before we engage into ECS.
Game, right? I mean, ECS is certainly, you can use ECS in production, but it certainly isn't necessarily considered production ready at this point.
So there it is, guys. That's an overview of the presentation. I haven't went through every single one of them because it's something very specific. However, you know what they're about now. Okay, let's speak a little bit more about should we use ECS? If you're in production, as the lady says, we maybe don't want to use ECS. We don't want to transfer our system. And if you are going to move over to ECS in a game that already exists, you want to be changing little part of it one at a time. You don't necessarily want to try and like implement pure ECS from the get-go. This is the approach I'll be going for. I will be going for a hybrid approach. Of course, I want to create games, and every time I see where there could be a huge performance gain, and I'm talking about a huge one. I'm not speaking about, say, if I only have one character on the screen that does, that moves around and like do behavior, like classic mono behavior stuff. Not a really good idea. If I have a batch of those that do something, like if I have an AI, a crowd AI, then yes, definitely use ECS for that kind of stuff. But don't use it for your player just yet. Wait a little bit, maybe, because it's going to change quite a lot, and your player is quite important to your game. You don't want to be waking up one day with an update to ECS, do your update, and then it just end up not working. That would just be quite bad. They don't have solution for camera just yet. They don't have solution for player controller just yet. They don't have solution for a bunch of things. But it's still worth using at places where you see fit. So, still worth using in a rain system. Still worth using in, they show the snowflake system. Still worth using in a batch rendering kind of system. English is really, really hard today. So to wrap this up, I give you the offering of the Dogo. What do you think about ECS, man? I think he's tired of my shit. So thank you so much for spending the evening with me, or the morning with me today. Really happy that we get to spend some more time together now. Really hoping to push this ECS a little bit further. Now we just talked about it today, but we're going to be implementing it, of course, in the future. There is the Discord, our Discord, of course. First link in description in all the videos. Join it. Join it. We talk about ECS a little bit more, and Prastiwar gave us a nice list of tutorials over here that we can get started with. Some of them are kind of outdated, but a lot of them are really, really good. The one I like the most, if I give you the link, is the second one. And it's the Unity tutorial that shows the spaceship demo we saw a little bit earlier, so all those performance gain. Quality. So join us, and in the future, I will be making my own ECS tutorial, guys. Thank you so much for watching, and I will be seeing you in Discord or in the next video. Cheers.
No. Well, there's that.